Hello everyone, we are Group 11 with following members listed here, and our project is NLP language correction. The overall objective is designing a user-friendly and time-efficient language correction program that could detect grammatical error and exhibit the due business of input sentences. So the system structure corresponding to the objective is listed on the right side. We have two versions of crawler. The first crawler is an optional choice for users since it has API-based functions that requires API key to be run. And the second crawler is automatically initialized when the user tries to run the whole program. We also have an AVL tree structure-based checker that contains the two listed methods here, and a user interface works for viewing input and output. Okay, so before the detailed discussions toward each function unit, it would be better to have a simple demo at the beginning. So let's click the running for this project. This is actually what the structure looks like after the git clone, and you can see like the user interface is automatically popped up. So here is the place to type in the path of the file that you want to be test, and this is the place that you want to type in the URL link, and let's randomly find one. This is the official website for the Boston government, and why I chose this is that for those kind of governmental official website, all the linguistic grammar are gonna be very accurate. So let's copy that things into, and we start the URL crawler to run. This could be possibly have an error which is shown in the middle, but this is something that shouldn't be worried, because when you just click the OK and it will just try to rerun, and we should just wait for until there is the information that pop up say like the crawler is finishes working, as you can see here. Now this is you can just trying to type in the path of the file you want to test. Actually, I have a file just called test in my root directory, so I can just simply type in test.txt. It can be some other files, but or anywhere in the computer, but then the absolute path of the file is required. So I just, in order to save time, I just don't want to type these things. I just click confirm. And I want to show the result, and the GUI actually pop up say like the checker is still working. We just need to wait. There it is. As you can see, each sentences are shown as a JSON format. But you can see, like, for example, this is good. It's definitely very oral common phrases, but for maybe in a formal written part, it's not quite formal and makes it like the suspicious score to be a little bit higher. But for the combination, you can see this is completely correct. That's for reasonable result for oral speaking. But like he's a good man is actually more like a complete sentences. So it's a perfect sentences which score as 0. And for the other thing, you can see this sentences actually needs it's not leave, which should be leaves, and give a small error. But for this kind of things, like the word so, hardly ever like appear after the adjective strange, and you can see the score will be higher.
Okay, let's talk about the crawler. Well, the crawler is a service for the checker. The goal is to collect the statement as a dictionary for the checker. At first, we need to give a URL as a starter as a seed. In order to ensure that the quality of the text is relatively good, it is better to pick up like the Wikipedia items website or the English article website as a seed. And it fetch HTML code and save them in local, parse HTML to extract the text and all the links to other URL. Divide it and cut the sentence to 2 or 3 words long items and save them in the dictionary. They are good statements for the checker. And then we will pick up another URL link and repeat it. In fact, there is a website list txt file in the local to save all the links we already crawled. We set a hash set copy of them and to check whether the links were already crawled. If we were already crawled before, and we can pick another. The dictionary is not done at once. If the program determined and we can run it again, the new statement can add it into the dictionary in the local.
Besides a crawler for website, we also make a crawler for social media, and we choose Twitter as our target. To be easier, we use Twitter 4G, which is an open source library for Twitter API as our basics. And to meet our requirement, we override part of code. Then we can get the tweets based on keywords. Plus, we develop an algorithm to delete non-language parts like URL, emoji, or username, so we can get clean sentences. And then we cut these sentences into phrases, and we use these phrases to expand our checkers library.
The main data structure we use in our project is AVL tree. After crawler get the data from the website, we will store them in txt file line by line. At the beginning of running checker, the program will automatically read each database line by line and sort them into AVL tree structures in memory. There are 2 main reasons we used AVL tree. Firstly, this structure is workable in our design, since the string could sort in lexicographical order by compare to function in Java 8, which means we could implement our data into binary search tree. Also, it works more efficient than our previous data structure, which is linked list. Even linked list has better insertion time complexity than AVL tree. The search complexity of AVL tree is much more better than linked list. And we only do insertion and the initialization part. The time consumption at this part is negligible. Searching will take majority part in our program, so AVL tree will give us better performance.
Today I'll be talking about the checker that we built. Firstly, I will talk a little bit about the background information. Our checker is able to assign confidence for various language structures, and of course, users can choose any text file they want, as long as it is a .txt file. The suspicious of all the sentences and phrases will be provided. 0 means not suspicious, and 100 means most suspicious. The output will be in JSON format. Now let me talk a little bit about the design decisions. Actually, our checker checks sentences in 2 main ways. The first method is to check all the phrases of the sentences. Our crawler crawls different webs and stores the processed data to the corpus. According to the corpus, each phrase will be assigned a confidence. The second method is to check some common grammatical errors. For example, our program will check the position of the noun and verb in the sentences, whether A and N was properly used, whether the quotation marks come in pairs, and etc. Each time we find any of these common errors, some scores will be added to the suspicious of the sentences. Finally, according to the suspicious of the phrases and the suspicious caused by these common errors, the final suspicious of the sentence will be generated. Okay, that's all. Thank you.